So let's use the ideal gas law now to solve some problems. So we're going to use it. Remember, it's PV equals nRT, where you have pressure, volume, number of moles, the gas constant, and temperature. Because of the units for the gas constant, liters times atmospheres per mole Kelvin, you now don't have a choice on pressures. They always have to be in atmospheres. There's nothing to match them on the other side. So you always have to convert pressures to atmosphere when you use this. Your volumes always have to be in liters or they're not going to cancel with the units on the gas constant. Temperature, of course, has always been in Kelvin, and we really don't have an alternate for moles. But remember the gas constant units when you're doing one of these problems. Okay, so let's calculate the pressure for 1.82 moles of H2 in a container, with volume. Volume equals 5.43 liters, and the temperature is equal to 69.5 degrees Celsius. So everything's pretty good there. Okay, we need to calculate P. We're going to rearrange this equation. We've got volume in liters, which you need, moles. Moles are moles. We have to convert temperature. So temperature is 69.5 Celsius plus 273 gives me 342.5 Kelvin. If I'm solving for the pressure, I want to get pressure by itself, which means I'm going to divide both sides of this equation by V. So I have P equals nRT divided by V. You can label things. I recommended that earlier. So here we have N, here we have V, here we have T, or here we have T. So you would figure out, I have to use the ideal gas equation. I don't have any P1s and P2s, T1s and T2s. I've got a static situation where things aren't changing. So plugging in here, the number of moles is 1.82 moles. The gas constant's 0.0821 liter atmospheres over moles Kelvin. I know you're getting unhappy with me writing that. Temperature is 342 Kelvin, or 342.5 Kelvin. And I am dividing that by the volume, which is up here. It's 5.43 liters. Liters are going to cancel with liters, kelvins with kelvins, moles with moles. We're left with atmospheres. So multiply that times that times that, divide by the temperature in Kelvin, and you get 9.42 atmospheres, which is a very high pressure. Let's try something a little bit different. With this one, I want to calculate the volume of 7.40 grams of CO2 at STP. Okay, whenever you see STP, you know that T is equal to 273 Kelvin and P is equal to 1 atmosphere. But what do? We don't have moles. You can, however, convert grams to moles. You guys all know how to do that. 7.4 grams of CO2 divided by the molar mass of CO2, which is 44 grams per mole. One more mole and 44 grams. Okay, carbon is 12. 2 oxygens are 32, 12 and 32, 44. So I'm going to do that, divide 7.4 by 44, and I get 0.168 moles. So now I've got a couple of things I can do. I can use the ideal gas equation. PV equals nRT, V equals nRT over P. Plugging things in really quick. 0.168 moles times the gas constant. And because I'm in a hurry, I'm not putting the units down. No, I am. I can't do it without too many years of habit. Temperature up here, STP 273 Kelvin. And the pressure is 1 atmosphere, which is nice because while the units will cancel, I don't have to do anything. I don't have to divide because I'm dividing by 1. And if I do that, and if I did it properly, I think I have 3.77 liters. Now remember the business about STP. We have the number of moles here. So if we want to use the standard molar volume, because we are at STP, this will provide us with a nice little shortcut. 22.4 liters in 1 mole. I've got the number of moles here, and I am at STP, so if I take my number of moles, 0.0168 moles, and I multiply by the standard molar volume, 22.4 liters in every 1 mole, the units of moles are going to cancel. I'm left with units of liters. And when I did the calculation, I was off by 1/100th. I had 3.76 liters here as opposed to 3.77 liters there. But that's why I said this little thing, the standard molar volume, comes in kind of handy if you remember to use it. But you can just remember the ideal gas equation and it still works out fine. It's just a little bit more complicated in terms of the math. That's it for this.